thank you, Bill, for a very warm introduction. So I'm going to just share stories today, no mathematics and no algorithms and so on. But hopefully through that, you can probably see the power of AI, and which is building on the recent big data revolution, as well as cloud computing and big compute, right? So with this, let's go to the next slide. And so spatial computing is a term which is relatively new, and just like we are imagining the new school here, about 10 years ago, we did a workshop like this at National Academy with people from multiple sectors to identify what all this has accomplished and what are the new opportunities. And you can kind of see GPS and Google Maps, which is on the top, are the public face of this area. But beyond that, Geo AI and many other things have been accomplished. So with this, let me show you a few stories, right? So first, many of us are probably using, location services such as Uber, Google Maps, and so on. But beyond those applications, GPS is also used as the clock. So if you look at electricity grid or even internet, most clocks are synchronized with GPS. And it has become so embedded in our lives that people think if it goes down, there may be major disruption, and they are building ground-based infrastructure. So this is kind of giving you a sense of this space. Of course, coming from environmental side, you see the maps and satellite imagery all the time, right? So this next slide is kind of giving you a little bit of history of this area. If you look at sort of the left column, okay, so left column are things from last century. So I don't know how many of us know about ArcGIS from ESRI. Few of us, great. So last century, this was the main software, and a few million people used it. They were trained in geography or GIS and so on. And there were a few other software which are listed below, like Oracle, Spatial, and so on. But as you come to the second column, you start to see Google Maps, Apple Maps, and things of that kind. And I can ask, how many of us have never used one of these, okay? So it goes from millions to billions, right, in a span of about 10, 20 years. And as you go to the rightmost column, you now see a second revolution. So the reason Google Maps, Uber, and so on are so popular is because GPS was open to public in early 90s because of certain reasons. And it took only 10, 15 years for it to just become an essential part of our lives. Now, a similar thing is happening to remote sensing now. In 2007, USGS gave away their satellite imagery data, Landsat. But today, with President Obama's Open Data Initiative, a lot more satellite data is in public space. So let's look at the right column, and let me ask, how many of us are aware of Earth on AWS or Google Earth Engine? Few of us, great. So with this, we don't have to now buy very big computers. We don't have to have very high bandwidth internet or networks to enjoy satellite imagery and make use of that. It's all on the cloud. You can go, and there are many startups and many applications that are being written. Okay, one close to my heart is on the bottom of right column, which is showing you agriculture applications. Right? So, and I will show you an example of that. So now satellites are being used to monitor agricultural health and also give advice to the farmer on how, what is the seed density appropriate for each part of the farm, right? And just to give you a dramatic story, coming from Minnesota, we have a company called Land of Lakes. How many of us have heard of Land of Lakes? Quite a few. What do you think is its main product? What's its biggest revenue getter? Butter, right? But in actually recent years, it's not butter, it's data. They are a cooperative. They advise a quarter of the farmers in the United States, essentially advising them how much seed to put where in order to manage the input. So with this, you also know in government, spatial data has been used for many different agencies, and you can kind of trace back a lot of things that Google Maps and other use, where did they come from? But instead of going through that list, let me actually go and show you actual stories, starting with a very old story. Okay? So spatial thinking and spatial data, has been around for a long time, as you know. But given the pandemic, one of the stories we should remember is the London cholera, 1854. And again, quick question, how many of us do not know this story of London cholera map here? Few of us, okay. So back then, people did not know how cholera was spread, and some felt it was spread through air, the Maizama theory. That's what scientists kind of focused on. But John Snow made a map, walking around London for several days, which is shown in top left corner, where little dots are the deaths and bigger squares are the water pump. And what he saw was these deaths were concentrated in one area, and the center of that was Broad Street water pump. So he came up with a different conjecture saying this water pump has something to do with the disease. And he went to city council requesting them to shut off the pump. But the pump was private and science was not with him, so it took a while. But one city official did take a chance and remove the handle, which is shown on the third picture on the top row. And that helped subside the cholera. Now, few years later, Louis Pasteur and many other scientists, they started pointing microscope at the water, looking for what is in the water, right? And that bolstered the germ theory, right? Which was around, but very few people believed it at the time. And today, as we know, germ theory is considered a turning point in science, right? Doctors wash hands before seeing patients. All of us wash hands, right, regularly. And our cities have been redesigned to separate wastewater from the clean drinking water and so on, right? So this story actually tells you two things. One, the essence of, you can call it geo-AI or spatial data mining, which is what John Snow was doing. Okay, so these technologies are very good for generating hypotheses. Okay? However, we should not stop there. Louis Pasteur and so on, what they did, you can call them as the physical science, right? Controlled experiments, theory building, and things of that kind, right? So both of them are necessary. So it tells you the strengths and as well as weaknesses of geo-AI or spatial data science. Okay? So you can ask, what are the choleras today and how may spatial help? And I'm going to just show you a few examples through this, right? But before we go there, since it is Friday, and Bill asked me to keep the talk very light. So, and some places, we have TGIF, right? In Berkeley, Stanford, after Friday afternoon seminar, people always went for a beer and drink. You need help. The AI machine learning has to help people prioritize and say, look over there. That's the most interesting thing today, and so on. Okay? And it's actually being used. And I'll show you a couple of examples. So in terms of data, there are a couple of data sets that spatial people are most excited about. The top left is talking about satellite imagery, and we just talked about it. But also the GPS trajectories. If your smartphone, if you left your location services on, then you know that not only smartphone companies, but many apps are tracking you. So we have GPS trajectories of people at a very high resolution, and that gives you some other insights about our lives, and I will show you an example. And then there are others. Most cars today actually, they measure hundreds of variables about your energy use, your emission, and those data sets are becoming available, and so on. If you are on social media, like Twitter, a large percentage of Twitter has a location. Okay, so even on internet, things have locations, and you can do something with that, right? So, okay, so we got the data, and why is it interesting? On the right side, I'm showing the business perspective, which is showing the top right is a National Academy report, and it is just saying that remote sensing data would be worth almost, over $1 trillion every year in just a couple of years from now. Right? So it is a big opportunity. And, if you don't, if you probably know what these numbers mean, but just to put it in context, let me ask you, the biggest company in the world, are their annual revenues more than this $1.6 trillion or less than $1.6 trillion? Yeah, it's less than that. Their stock market value may be there, but the revenues are not there. Revenues are still $500 billion or less. So this is a big number, and that's why every big companies, whether the tech companies like Apple, Google, and Amazon, or whether it's oil exploration or car manufacturing, all of the big companies are after this market. So there is commercial interest. But it's also of interest to societal things. So we can solve societal problems with this, and I'm going to show you a few examples. You can start to solve previously unsolvable problems, and so on. So here is one. We had Arab Spring. Anyone remember Arab Spring about 10 years ago? A few of us, okay. I mean, people said it was because of Twitter, but real analysis shows it was because of food prices going up, okay? So after this, many countries said, well, we don't want to be in this situation again, so we want to have transparency about the crops and the yields around the world. And about, I would say, more than a dozen countries which used to have satellite back then, they came together and say, we'll monitor world crops. And this map is showing you one of the reports. Every month they produce this report, and the colors tells you the condition. This is a little bit older, but yellow areas, for example, US Midwest, you are saying crops were not doing well, or close to Kenya, Somalia area, or in Argentina North, and so on. But essentially looking at this data, now you can project end of the season yield. And if a particular country believes that they are not going to have enough local production, they can start planning import or take things from their storage and so on. So you have a lot more time to plan for any possibility or any risk of food shortage. Okay? And this is produced every month. It is used by every single commodity market companies, the food companies. It is used by government and so on. Right? So, but how is it produced? When the satellite imagery starts, that gives you the basic data. But after that, the first round is actually to run machine learning, which runs through the satellite imagery to classify crop health. And then you also run models to project that to end of season yields, right? Now, there is a lot of diversity across the globe. So the satellite sensors are different across countries. The machine learning algorithms are different. But at the end, the reason it takes a whole month is actually they go and do the ground truthing, because this is a very serious, right, issue. You cannot have a lot of errors. The hallucinations of the chat GPT is not acceptable here, because the errors means the governments are toppled. That's what Arab Spring shows you, right? So there is a whole procedure of quality control and so on. Okay? So this is one example. Here is another one close to the last few years. So during COVID-19, many measures were introduced, such as stay at home and so on. But the question was, were people really staying home? And one way to actually answer that was to look at the cell phone data. So how many of us were aware of this SafeGraph COVID-19 consortium data that was made available? Few of us, okay. Basically, this data set is privacy protected. It's very much like census, except that census happens every 10 years, and this was happening every minute. And it was reporting the number of cell phones in different geographic areas by the minute. And also, you could essentially look at the movement of the people by census block or by zip code and so on. You could look at where people were going and things of that kind. So we were fortunate enough to be asked by one of the Minnesota government departments to monitor this, publish the report, which they could use. And this actually, the pictures, the top right is actually showing you the fraction of cell phones in different areas of Minnesota whose locations were being reported. It was roughly 5 to 10%, but little variation. The bottom pictures are showing you something completely different, which was basically Minnesota was thinking about, can we safely reopen some businesses, right? Restaurants and things of that kind. And our analysis actually showed that it was safer to open the limited service restaurants because people were not spending much time there. They were coming and picking up, but full service restaurants, it was not safe to open because when people go there, spend a lot of time. And you probably saw the measures that they started putting seating outdoors and things of that kind. But all this is again saying is this is a completely new data set. Your cell phone locations, if you aggregate it in a privacy protected manner, you can start to see patterns of life of very different kind, which may be important to major decisions for us. Okay. So let's take something even further out. I know we are interested in climate change and reducing the carbon footprint and so on. So in this context, we are first going to show you another data set, which many of us may not have been aware of. But so the bottom left picture is actually showing you that cars emit, right, a lot of data set. If you have seen your check engine light, it's just part of that. But you can use that data set to pick up eco-routing, routes that minimize energy or emission rather than travel time. In fact, Google, we have been doing this work for 10 years, but Google Map made it available about a year and a half, 2 years ago. Has anyone used eco-routing on Google Maps? Great. So another big, big data and AI kind of a application. This is our, we just started on this grant, and now I can be called an AI person, even though my thesis was in AI in 80s, I deviated, I was doing some more geographic problems. So we are fortunate to be given one of the national AI research institutes, and it is focused on climate smart agriculture and forestry, where again, we are looking at various data from the ground sensors as well as satellite sensors to understand soil carbon sequestration potential of agriculture and forestry. Okay. And there are others as well. Open seas, it was very difficult to monitor illegal fishing and, trades which were restricted and so on. But 10 years ago, ships are now required to report their location to avoid collisions. And you can look at that data to make a map of not only where ships are, but also bottom right, you see this yellow line, a shipping container near Galapagos, is reporting location for a while, but just bottom left of that red area, Galapagos, you see they stop reporting location for 2 weeks. Question is what were they doing for 2 weeks? If you do the traditional interpolation, then you will say, well, most ships go off the marine habitat, only scientific ships go in the habitat. But if you use a estimation of worst case situation, where could they have gone? Probably this is one where analysts should look at satellite imagery and check and take a second look. Okay? And there are now yet another data set I will mention. This is very new, but when you look at cancer biopsies, now the microscopes are such high resolution, we can make a maps at the cell level. So on the left-hand side, those little dots and in colored dots you are seeing, they are maps of the cells in a cancer biopsy, the cancer cells and the healthy cells and immune cells. And the conjecture is that once we have these maps, by looking at the spatial configuration, you can develop cancer immunotherapies. Because cancer cell next to killer immune cell is a good news. But if there is a regulatory T cell preventing that killer cell to killing the cancer, that's not a good news. And then you have to develop schemes to kind of break that, and those are called immune checkpoint therapy. But again, you kind of see that we have a lot of new data, and finding these spatial patterns, you can do interesting things. So this is the last slide, and all I'm basically going to share is that story has only begun, and a lot more exciting things are next. This is what Scientific American said just a couple of years ago. So AI, machine learning, it's worth trying. I mean, there are some risks and dangers, and that's where you do want to work with the people in the field, get the right regulation, get the right quality control, sort of like what was done with GeoGlam for agricultural monitoring. But certainly these technologies can open new doors, help us solve new problems. So with this, I will stop and see if there are any questions. Okay. Yeah.